All right, welcome back, everybody. We're going to do a review of Chapter 4 today, going over the practice test. But I know we were all excitedly waiting to hear Hayden's story, so I decided to record it. This is problem number 1 off the practice test. Problem number 1 off the practice test. Do I have it scanned in here? Oh, I guess yes, I do. So we're looking at that graph. Let's attempt to follow along with Hayden's story and try to match it to the graph that we see on the screen. Without further ado, Hayden Rudder, everybody.
All right. So once upon a time, this is a great time.
Now, Hayden, you got to speak up because of the.
Oh, all right.
You can you can stand over there. You got to be loud.
Stand right there, so it's really loud in the video.
Okay.
All right. Once upon a time, it was a great time. It was summertime. All right. It was a very fine morning, but the sun, it was a deceiving sun because the air was cold to the touch. There was a little layer of moisture around the windows, as per usual. But their mother said, "Don't go outside because you might catch a cold," even though it's summertime, and that makes no sense, but it sounds like my mom. So, yeah. All right. Then they said, "You know what? I think I'm going to go outside." Jimmy and Gerald, the two of them, they went outside. They got their kiddie pool, threw it inside, but Gerald, he had gone into the hose because he couldn't reach the sink. He didn't think of standing on the stool because he's only like yay tall, about, waist height. So he had gone to the sink. Well, he didn't go to the sink. He had gone to whatever cup that he could reach, which was quite a few. He was filling those up, so you couldn't tell the graph is about to be thrown in. The water level is about to go up. All right. So then the two of them had taken the cups, thrown it in the basement with the kiddie pool, started filling it up. See, the water level's going up.
Yeah, you're doing good.
All right. And then for the time they had gone and thrown on their swimming suits, as you would do when you go into a pool.
Right.
All right. And then they started getting in, and then their mom had said, "You know what? It's getting a little chilly because it's cold outside." So then she turned on the heat. Now, that's the water level going down a little bit. They're always getting in and out, so the water's sticking to them, and then the heat, there you go. And then they're like, "Man, we're out of water." So while one's just still sitting in there, it's empty, completely empty, the other one's going and getting more water. So then it fills up, and then you see that little flat line there?
Yeah.
That's just the end.
That's just.
But it's not quite over.
Oh, it's not quite over.
It's not quite over. See, here's the thing. This was all a dream. This is all the dream of their mother. So then she had gone outside her kiddie pool, thrown it in the barn and locked it up. But the two little devilish kids had figured out how to pick locks in their free time. They had gone to the barn, they had opened it, and they could not find the kiddie pool. Mostly because it wasn't in that barn. There was multiple barns all across the yard. They had just gotten them in last week. And they all had different locks, different kinds of locks too. So the two of them had gone to each and every barn, and finally, on the last barn, they still didn't find it because it was in the neighbor's barn. So then they'd gone to everybody's barn, and of course, the last one they found, it was in there. So then they had, carried out their plan like they were going to. And yeah, that's it.
The end.
Yeah,
Oh,
the end.
that's the end. Yeah,
You're supposed to write that out.
Very good. Hayden Rudder. Yeah. Wow. That was. I gotta be honest. No, let's not write a story that long on the test.
I took notes.
You took notes? Okay.
I wrote
I'm glad.
it down.
All right. So that's number 1. Anybody have
Number 2.
anything else to contribute? I hope not for number 1. Okay, good. So I'm gonna read off names for the rest of them, like we always do with practice tests. There's not many questions here, so you might all well. Number 2. Number 2 is going to be Travis. Actually, Travis. Number 3 is Will. Number 4 is Serenity. Please remember your numbers. Number 4 is Serenity. Number 5 is going to be Kyler. Number 6 is Mr. Schrembeck. Number 7 is Taylor. Number 8 is Elena. Number 9 is Hannah. Number 10 is Mackenzie. Number 11, Liam. Number 12, John. Number 13, Mason. Number 14, Hayden. Hayden, you're going to do 14 and 15.
Okay.
Well, because 14 you graph the scatter plot, and 15 you draw a line. And, yeah. 16 is going to be Baker.
No. I thought I wasn't gonna get
17 is going to be David Haas. If you weren't called, then you don't have one. Okay, so if you got a graphing problem, make sure you're graphing it on the whiteboard. Let me get out some. They should be around the room. They should be. We get you guys some markers if you need some. Oh, you go. Yeah. Okay, very important.
That's a lie.
No. That's one X value can't go to 2Y.
I was drawing there.
What? Anybody need a marker? Anybody need a marker? Does anybody need a marker that does not have a marker? No. What? Oh.
There you go.
If you do a top, you use that.
Hold on, just 1 second.
Number 3 confused me because I wasn't sure if you actually has a vertical line.
Oh, no.
Go ahead. Go ahead. Hey, put it high to Yeah. Yeah, it didn't say like when X is. I think I put that like 11. Oh, what? Don't repeat when you're writing out the range. You only write it once. Yeah, so label your answer. What's supposed to play with the numbers? And use your hand with the, what it is. Oh, wait, but label it with numbers so that you can tell the line from 10 over. Yeah. What number is it? Why do we put the number up? Make it always make it an amount.
Yeah.
You very distinctly hear that. No, thank you. What is that? Oh, it's a door. That's yeah. Okay, that's fine. Good. Oh, they're like, oh, I'm still eating Christmas lunch. They still get. Well, I take it back. Excuse me. There you go. There it is. That's it.
But you see how that.
You already have it.
Yep.
Oh, yeah.
Hey, as long as the recording doesn't end up 50 minutes long.
There we go. All right. So let's talk through. Shh, quiet, please. Quiet, please. Quiet, please. Quiet, please. Quiet, please. If you're not done, please finish up. Let's talk through the answers here. We already talked through number one. Number two. Who had number two? Who had number two? All right, good. Travis is showing -3 is less than or equal to x is less than or equal to 2. -2 less than or equal to y less than or equal to 4. Good. Just for everybody playing along at home, the domain again, left to right, -2 to +2. You said 2, right? -2 to +2? Oh, sorry, -3 to +2. -3 to +2. Sorry. And then the range is going to go bottom to top, -2 to +4. -2 to +4. Good, that's the answers for those. Questions about that one there? Number 3, give the domain and range and tell whether it's a function. Please show that to the class there. The domain should be -3 to +3. -3 less than or equal to x less than or equal to +3. The range, again, bottom to top, -2 to +2. -2 less than or equal to, oops, sure that's a y. -2 less than or equal to +2. Good. Now, is this a function? Will says no. No. Why not? Why not?
It doesn't pass the vertical line test.
Right, it doesn't pass the vertical line test. If I go right here, it's going to hit twice. It does not pass the vertical line test. Good. All right, number 4. Who had number 4? Who had number 4? Trinity. She said the independent variable is the size of the room and the dependent variable is the total cost. I would agree with that. New cost of getting new carpet is based on the size of the room. So the independent variable is the size of the room. And the dependent variable is the total cost. Good. Remember, whenever you identify what the independent and dependent variable is, you should be able to say in the end, if I change my independent variable, it will cause my dependent to change. So if I change the size of the room, it will cause the cost to change. That's a true statement. Okay. Any questions on the front? Okay, let's flip over on the back. Again, you should be writing correct answers in, right? Everybody should be writing in correct answers for each problem. All right, number 5, data was collected from a random group of students on the hours spent studying for a vocab test and the score received on that test. Identify the correlation you would expect to see between the hours studied and the test score. Who had this one? Tyler did. He says positive correlation. The more hours spent studying, the higher the grade. Good. I would agree with that. Positive correlation. Positive correlation. Good. Number 6, determine a relationship between the x and y values. Write an equation. Who had this one here? Mr. Schumbeck. Good. I would agree with that. Now, he wrote it as y is equal to x times negative 6. That's totally fine. I would probably put the negative 6 in front so that we don't confuse it with a minus sign. Y is equal to negative 6 times x. A lot of people are getting really confused with these ones, guys. Just look and see what operation is going on to x to get it to y. Okay? You know, based on that first ordered pair, maybe it's just a minus 7, a subtract 7. But that doesn't work for the second ordered pair. So you got to come up with something else. Well, it's a negative 6 times that value. Okay. Number 7 here, express the relation for the test as a graph. It's a table, graph, and as a mapping diagram. I believe I have one already set up over here. Yeah. Who had this one? Who had this one? Who had the table, graph, and mapping diagram? Yeah, number 7. Number 7. Number 7. Bueller. Bueller. No. Anybody? Okay, Mr. Laverick's going to do this one. Number 7. Maybe somebody was just like, yeah, I'm not doing that. 2. Oh, get that. I want 2, 5. Got 3, 2. 4, 1. 5, 3. 5, 7. Okay. I graph. I say 2. That's what 5. 2, 5. 3, 2. 4, 1. 5, 3. 5, 7. Okay, there's my graph. My mapping diagram. My domain is 2, 3, 4, and 5. Do I write 5 twice? No, I remember grading last year's tests, and maybe I forgot to say it as much. Guys, do not, because I had to take off points for this a lot. Do not write your x values more than once in a mapping diagram. Do not write your x values more than one, or your y values. Along the right side, I should have a 5, a 2, a 1, a 3, and a 7. And now when I connect my ordered pairs, it goes 2 to 5, 3 to 2, 4 to 1, 5 to 3, 5 to 7. Is this a function? No. For multiple reasons. I have 2 x values coming out of two y values, 2 arrows coming out of one x value. And I also can see that it does not pass the vertical line test either. All right, that's number 7. Who had number 8? Elena, thank you. Number 8, let me jump back to here. Number 8, it says a music club costs $10 to join. Each song that is purchased costs $1.50. Let S represent the number of songs, identify the independent and dependent variables, then write a rule in function notation for this situation. Okay, Elena says the independent variable is the number of songs. Good. The independent variable is the number of songs. And the dependent variable is the money, the total cost. Okay. Oops. Sorry about that. Now, the equation that Elena wrote is f of x is equal to 1.5x or 1.50x plus 10. Perfectly fine. I would accept that. What's the only thing that maybe someone would change here? There's only one thing that I would not take off for, but maybe like if you're doing this on the OST, they might take off for it. What's the only thing we would maybe change? What's that? No, f of x is okay.
Would it be because it said use S?
Yeah, that's the only thing maybe that somebody might say. Okay, maybe we would say cost as a function of s because they said let s represent 1.5 s plus 10. Although I really don't like s's and 5s next to each other, right? All right, so but again, if you wrote f of x, that's totally fine. That's probably what I would do too. I'm boring like that. Questions about 8? Okay, let's take a look at 9. Number 9. Good. Now remember, for numbers 9 and 10, all you're doing is plugging in those values. So everybody take a look up here. All you do to find -2, or find the y value when it's -2, you plug in -2. -7 times -2 minus 15, which we get -1. -7 times -2. So f of -2 is -1. What'd you get for f of 3? What was that? -36. Yeah, because it's 3 times -7 is -21. -21 minus 15 is -36. Good. Those are my two answers there. Make sure that it's written in function notation. Guys, everybody take a look at that, because that's another thing that I might take off points for. Make sure that that answer is written in function notation. F of -2, F of 3. Okay? Same thing for number 10. Who had number 10 here? Oh, Mackenzie's turn. So we plug in 5. We find f of 5. So it'd be 3 times 5 squared. Remember, I had somebody ask me yesterday, do I multiply by 3 before I square it? No. You take 5 squared, then you multiply it by 3, and then you subtract 5. 5 squared is 25, times 3 is 75, minus 5 is 70. Good. And then f of -4, be careful there. You want to use parentheses when you plug that in. I'm going to show it in your calculator just so you see where to use the parentheses. I have 3 times -4 squared minus 5. Positive 43. Make sure you use parentheses by putting the -4 inside the parentheses and then squaring it. Okay. Questions on 9 or 10 before we move on past that? Okay, let's talk about 11. 11, 12, 13, 14, and 15, those are all graphing ones. So I might jump back to, I think I have some graphs set up for me. Yeah, this is 11, right? This is what you guys have for 11? Okay, good. 11. Okay, let me ask you guys. Okay, this looks good for a straight line. Right, -2, comma, -8, 0, comma. Uh-oh. Oh. Wait a second. -2, oh. Okay, what? Yeah. Watch out here. What did he do? You didn't do the right domain. Look at the problem. I gave you a specific domain to use. You see that? Yeah. And also, in the end, I looked at this right away and I saw what? What do you guys see? Connected the dots. Should you connect the dots? No. You should not connect the dots. Okay. So let's go through this one. I was going to do it on the board anyway. Let's go through it. -2, 0, 2, and 4. Let's plug it in. 3 times -2 minus 2 would be -8, which I believe that's what you had. 3 times 0 minus 2. I think you had 4 for this. 3 times 0 is 0 minus 2 should be -2. 3 times 2 minus 2, that's 6 minus 2 is 4. 3 times 4 minus 2, 3 times 4 is 12, minus 2 is 10. Okay, now I go and I plot my points. -2, -8, 0, -2, 2, 4, 4, 10. Which is what your graph looks like. Just
I put these numbers, the x values on this wrong, but on paper I did it right.
Oh, you did it right? Okay.
Yeah, I didn't.
Oh, you know what you did? Yeah, that's right.
Yeah, and then the graph is right. I just.
The table is just weird. Okay, got it. Just make sure, don't connect your dots. Don't connect your dots. And again, why don't we connect our dots? Let's say that one more time. Why don't we connect our dots? Because I gave you the domain. I gave you the domain, so don't connect your dots. Number 12. Who had number 12 here?
I did.
B. Good. Now I see a V shape. Perfect. Awesome. Plotting points, -2, -1, 0, 1, 2. Absolute value -2 is 2. Good. That's exactly right. Good. The only thing I would change, put arrows on the end of your graph.
All right.
I probably wouldn't take off for that, but remember, we want to show that it's going to go on forever. So to show everybody at home, we would do -2 plus 4. Remember, there's nothing in your calculator that will do the absolute value. You have to do that for yourself. The absolute value -2 is +2, plus 4 is 6. The absolute value of -1 is 1, plus 4 is 5. The absolute value of 0 is 0, plus 4 is 4. The absolute value of 1 is 1, plus 4 is 5. The absolute value of 2 is 2, plus 4 is 6. So -2, 6, -1, 5, 0, 4, 1, 5, 2, 6. Graph your lines. Make sure you put arrows on the end. And that's a V shape. We know it's going to turn out to be a V shape because why? Absolute value. Good. Questions on 12 before we move on? Okay, let's take a look at 13. Put 13 here. Good. 13, we got 3x squared plus 2. Yeah, show everybody else. That looks good to me. -2, -1, 0, 1, and 2. We plug in. We say 3 times -2 squared plus 2. Okay, remember putting that in your calculator there. It should say 3 times -2 squared plus 2. Should look exactly like that, which is 14. Then we do 3 times -1 squared plus 2, which should be 5. 0 turns out to be 2, and then these y values do repeat. -2 comma 14. Okay, -2 comma 1, 2, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh, perfect. 14. -1 comma 1, 2, 3, 4, 5. 0 comma 2, 1 comma 5. Now, it looks pretty steep, right? But it should round out at the bottom there, right? Let's try to hit the points there. Good. Again, and I am connecting the dots because the domain is not given to us. We connect the dots when the domain is not given, when we create those 5 coordinates. Good, number 14. Hayden, you had this one, right?
Yeah.
Sorry, I figured you had number 1, so you didn't have to do it. Okay. Got it. Good. Yeah, everybody take a look at that. Hayden, show yours as well.
I was going to say 15. My graph's messed up because it's jarring, because it's like the thing. But yeah, I said positive and 0.8, and then 15 I said 11.
Got it. What did you say when you're like for x value is 15?
I had about 13.5.
Okay. See, I have to accept like anywhere in there, right? I can't really. I have to kind of give you a wide variety of answers. Here's what I'll look for. Okay. I'll look for. Are you drawing out that line so I can see? Here's what I mean. Here's 14 and 15. I'll show it for everybody playing along at home. We got 3 comma 5. 1, 2, 3, 4, 5. We've got 6 comma 8.5. 3. 1, 2, 3, 4. Here, I'm going to do this. 5, 6, 7, 8, 9, 10. Right. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So we've got 6 comma 8.5, 6 comma 8.5, somewhere right there. We've got 5 comma 9. We've got 2 comma 4.5. We've got 7 comma 9. We've got 4 comma 7.5. We've got 8 comma 11. And we've got 1 comma 3.5. Okay. So there's my scatter plot. Right, there's my scatter plot. We see that it is a positive correlation. You know, if I was asking you the R value, you would say the R value is probably around, you know, these points are pretty close together. Right? The points are pretty close together. I would say my R value is 0.8, 0.9, something like that, maybe 0.7 if you wanted to. Let's say 0.8. Now, number 15 says, draw the line of best fit, done. Predict what Y value would happen when the X value is 10. Okay, so if I just make that go a little bit more. Here's what I mean. I want to see your dotted line going up, and then I want to see your dotted line going over. For my scatter plot here, you know, was I very careful when I drew this line in? No. Okay. The line of best fit can be kind of anywhere in there. So that means your value at 15 or at 10
Could be very different.
it could be very different. And that's okay. I want to see this then. Right? I want to see you write it. I want to see you like line it up. So here, it looks like to me it's 11, 12, 13. It's about 13 when X is 10 for my scatter plot there. Again, I would probably accept anywhere from 10 to 15, 17, somewhere in there.
Yeah. We just already got the about sign.
Oh, that's questions on 14 or 15? No? Okay. Let's finish it up here. 16, 17, and 18. Or sorry, just 16 and 17. There's no 18. Give the domain and range of the relation. Tell whether the relation is a function. Go ahead, 16. Baker. Of course you would write it that small.
Hey, I have this marker. Joe's got the red one.
Yep, I wrote that. That's your problem.
I would like to see.
That's not a
So the domain
Okay.
is, now be careful here, folks. Watch. Everybody eyes up here. Do I write 2 twice? No. 0, 1, 2. My range. None of them repeat, so it doesn't matter. I'm going to put them in order, though. -2, 1, 2, and 5. You don't have to put them in order, though. Is that a function? No. Why not? 2 twos. 2 twos. I've got my X values are repeated. The X value of 2 is repeated. Questions about 16? Okay, 17. David, you had 17, right? Looks like the domain here, good, 0, 1, 2, and 3. Nothing's repeated, so list them all out. And then the range, do I repeat -3? No. Say -3, 0, and 5. Is that a function? Yes. There are no X values that are repeated there. Okay. All right, questions on any of the practice tests? Yes.
You know how homework can I do?
Yes, you do. Your homework is to study, Carson.
I want you to memorize my entire story.
Hey, shh, remember, this is your first big grade of the second 9 weeks. This grade's gonna stick for a while. You know, it'll all come out in the wash in the end. But this grade is gonna stick for a while because it's the first grade of the new 9 weeks. Okay, be careful. See everybody home. So long.
The best kind of homework would be